Hi everyone. For two arithmetic sequences, a sub n and b sub n, we're going to find the value of a positive integer k such that a sub k equals 15. Now that just means that in our first sequence, we have a term that equals 15, and we need to know what position that is in. Which term is it? We also have that our first two terms are the same for both sequences. Our third term of the first sequence equals the fifth term of the second sequence, and our 21st term of the second sequence equals 15. So the only thing we really need to do with this before we work it out is set up our common difference. So that would be for our first sequence, a sub n, let's let that common difference be d sub 1. And then for our second sequence, b sub n, we'll let that common difference be d sub 2. All right, now looking at this piece, we have a sub 3, that's going to be a sub 1, plus, and then we use this, 3 minus 1 is 2, so 2 d sub 1. And b sub 5, that's going to be b sub 1, plus, and then using this again, 5 minus 1 is 4, d sub 2. However, since our first terms are the same, I can rewrite this as a sub 1 plus 4d squared. I also have that these two equal each other. So if I have a sub 3 equals b sub 5, then I have a sub 1 plus 2d1 equals a sub 1 plus 4d sub 2. So the first terms cancel and you get 2d sub 1 equals 4d sub 2, or you could say d sub 1 equals 2d sub 2. All right, we have that. Let's go to this one now. Our 21st term for the second sequence is 15. So I can write that as a sub 1. I'll just put b sub 21 equals, you can put b sub 1, but that equals a sub 1. So I'm just going to put a sub 1 plus. Now 21 minus 1 is 20, so that's 20. And that's going to be d sub 2. But I can write this with substitution and write this as d sub 1. So that would be a sub 1 plus 10 d sub 1. Now by definition, this equals a sub 11, right? Because a sub 11, using your formula, would give you that a sub 1 plus 11 minus 1 is t, d sub 1. So this is your k. Therefore, k equals 11. Thank you. Have a nice day. Bye-bye.